All right, here's just a couple of points on some trig stuff. First question, someone asked if you can change a decimal to a square root. I guess by definition, square root is a non-repeating decimal, so it never repeats. But if you just write a decimal number, say like 0.5, um, you don't know what comes after that. And so, yeah, I could write that as a fraction. I could say, well, a half is the same as or zero point 0.5 is the same as 1/2. But that could have been this number, right? That somebody had just rounded off. And so to convert a decimal into a square root, can't really do that. Um, Maybe there's ways that I don't know, but you can't really do that. You can convert, of course, square roots into decimals, but they would be approximate numbers. Now, probably where this arises from is you might be doing a question where, um, I don't know, you might have a question that says sine of an angle is equal to a half. And then what you do is would that be right? No, no, no. Say you have one like this where you have sine of sine of 60 would work. Sine of 60 is equal to, and you do that, and it comes out to 0.866. But then in the answer in the back, it has root 3 over 2. And you're wondering, how can you get from this to this? Well, really you can't, but you can get from this to this. This, where you come up with a square root, or this would be an exact answer. Square root would be exact, and this would be approximate. Where you come up with this is from a table that just shows the ratios between sides of specific angles. So you might have seen this table in section 6.1 near the end, where the sine of 30 is a half, sine of 45 is root 2 over 2, sine of 60 is root 3 over 2, cos of 30 is root 3 over 2, root 2 over 2, 1/2, and then this is uh, root 3 over 3, I think. I always forget this one. 1 and root 3. Something like that, anyway. That's funny, I always forget that last one. Anyway, so if you see something that says sine of 60, rather than doing it on your calculator, instead of saying that's 0.866, you can say that it is, you look up under sine, and 60 is right there. You can just say sine of 60 is root 3 over 2. Also in the book, they show you triangles where, like the 30, 60, 90 one, looks like this, and this is 30, and this is 60. And then if we're looking at this angle here, then this side would be 1. Is that right? This side would be 2, and this side would be root 3. So the sine of 30 is 1 over 2. Cos of 30 would be root 3 over 2. And tan of 30 would be 1 over root 3. Oh, is that the same? 1 over root 3 times both by root 3. Yeah, that's the same. So, so you could use that triangle, or you can use this table. Point of the matter is, can you go from a decimal to a radical? I guess knowing that root 3 over 2 is 0.866, you can say, well, if you get 0.866, that's the same as root 3 over 2. But on your calculator, I don't know of a way of doing that. All right, the other question that somebody had was sine versus cosine graphs. The normal sine graph starts here, and it goes up to a positive 1 and down to a negative 1. And it does that in 360 degrees, or it does that in 2 pi radians. So 360 are degrees, 2 pi radians. So it goes up, comes back down, goes back up. If you look at a cos graph, it looks identical, but it starts at a different spot. It actually, well, I always say it starts here, and then it comes down, and it reaches, am I doing this right? Reaches the bottom here, then comes back up, and then goes there. Now, I don't know if these would be changed. No. Let me just see if I can do this. If I can ungroup all those. Can't, darn. Anyway, that red one it's the same pattern as the black one. And actually, each of those keep going. Like this one keeps going forever this way. And the black one also keeps going forever that way. And so if you look at them, you can just take one of them, and if you move it over a little bit, it looks exactly like the other one, and you couldn't tell them apart. So for example, the black one, I would say that graph is y equals sine x or sine theta. If you look at the red one, I'm saying the red one is y is equal to cos x or cos theta. But the red one could also be a sine graph. And it could be a sine graph, whoops, that's just been moved over to the left. So according to our transformations, we could say, well, it's sine theta. Since it's going left, I'll put a plus here, and it goes left over by that much. Now, if this is 90, 180, 270, 360, so if this is 90, then I got moved over 90 degrees. So I could write 90 degrees there. So this graph, sine theta, oh no, not that one. This graph, y equals cos theta, and y equals sine theta plus 90, they're identical. They're the same graph. If you graph them on your calculator, you can't tell the difference. There'll be one on top of the other. When you graph them on the calculator, you got to be careful with this. If your graphing calculator is in degrees, you can put the 90 in there. But if your graphing calculator is in radian mode, you'd have to put that in as pi over 2, because that's what it would be in radians. But those graphs would be the same thing. Also, like the black graph, this sine graph, so the y equals sine theta, I could say it's the same as this cos graph. It's just that it's moved over to the right 90. So I could say this is the same as cos of theta moved to the right, so it'd be a minus 90 degrees, or cos theta minus pi over 2. Those graphs are the same. And you could do lots of different transformations to get so the graphs are bang on the same place. All right, hopefully that helps with those two questions.